All right, so now we know about our two different rates of change and how to find each one. Now we're going to talk about a new notation. All right, so both of these things have to do with slopes of lines and they have to do with changes. All right, so the kind of instantaneous rate of change is the thing that's going to come up a lot in applications. So we're going to create a terminology and a notation that'll help us kind of easily reference them. All right, so the first thing is the slope of the tangent line at x equals a. All right, this is our brand new definition for this unit, and for the next 4 units is the derivative of the function. All right, so the derivative of the function is known, or is the same as the slope of the tangent line. So every single time you see derivative, think about slope of the tangent line. All right, so tangent line comes first, you take the slope of that gives you the derivative, which is also the instantaneous rate of change of that function. All right, so all these things mean the same thing, all right, but remember derivative and slope. The notation is actually pretty simple. If we want to talk about the derivative at a of the function f, we just put this little prime, right, this little tick mark. So when I write it by hand, it'll look like that. I just put this little tick mark there. I represent I'm doing the derivative instead of the original function. All right, so this means the slope of the tangent line at x equals a. All right, so there's a lot of stuff kind of encoded in that simple expression. F prime represents derivative, which means slope of the tangent line, and the thing in parentheses represents the value I care about. All right, so if we want to estimate, I will figure out how to do these more precise in the future. But right now we're kind of just estimating. So f prime of 6, I have my x value is 6, which is here. So I need to first draw a tangent line. Well, a tangent line, as my graph is going along here, it's kind of going down in that direction. It's the lines that kind of keep going in the direction that your graph is going at that time. All right, so this is approximate tangent line. All right, again, that's why we're estimating here. All right, so if we're approximating this tangent line, if I keep drawing it, f prime is the slope of that. All right, so remember, slope is a bunch of different formulas, but the simplest one in terms of graph is rise over run. All right, so it looks like my line's not perfectly straight. Maybe if I made it a little bit more straight, it would go straight through there. And then I would have this point here and this point here. All right, my rise, I have to go down 1, 2, 3, 4, 5, and my run is 1. So my rise over run, the rise, I'm going down 5, so that's -5, and my run is 1. All right, my slope is -5, which means my final answer, the slope of the tangent line at x equals 6 is -5. All right, so the derivative at 6 is -5 because it's the slope of that red line. All right, same thing at 3. 3 is down here. All right, I'll talk about more how you can kind of figure out where the tangent line's going in class. It's kind of hard to do on the video, but if I think about if I were to just get cut off right at that dot, I'm making this turn, and then if I didn't have any more information like that, all right, this turn would happen, and I would just keep going straight down there. This tangent line ends up being like this, all right, because it's going downward on the left and upward on the right. Well, in between down and up is just flat. So f prime of 3. What is the slope of that line? Well, there's no rise over whatever run you pick, is just 0. All right, so this one is f prime of 3 equals 0. The slope of that tangent line, that slope of that line at 3 is 0. And this is actually a really important thing we'll focus on in a later unit. All right, the fact that this is at the bottom here means that my derivative is 0. All right, but we'll talk more in class about how to kind of draw these tangent lines first, and then estimating the slope is just rise over run. All right, so in class, we're just gonna kind of practice these things. We're gonna practice some average rate of change to help us find the instantaneous rate of change, all right, because you can do that approximation like we did in the previous video. All right, we're gonna do what we just did by looking at a graph and figuring out what the derivative is gonna be. And we'll just do some work with interpreting the prime notation. What exactly does the prime mean in context and other things? And then once you understand all of that, you'll be able to slay the day.